for everyone, welcome to my YouTube channel. Today we will discuss the paper that were in Thursday 9 January 2020 about chemistry unit 4C H1 science double award for SDO paper 1C. Let's start. Before starting, please subscribe my YouTube channel. Okay, the first question is, this question is about gases in the atmosphere. The box gives the names of some gases in the atmosphere: argon, carbon dioxide, helium, nitrogen, oxygen. Choose gases from the box to answer these questions. Each gas may be used once, more than once, or not at all. Okay, identify a noble gas. Okay, there have argon, that is noble gas, and there is helium, that is also a noble gas, but they have written a noble gas. It means that you can write argon, ether, helium. Okay, identify a gas that makes up about 78% of the atmosphere. It is nitrogen. It is written in the Pearson Edexcel ICC chemistry book, and you can read it from there or you can search it from internet. The next question, identify a greenhouse gas. We know that the greenhouse here is carbon dioxide. The next one, identify a gas produced by the thermal decomposition of calcium carbonate. Okay, the composition of calcium carbonate looks like this. Calcium carbonate will go to calcium oxide and calcium and carbon dioxide. Means that the gas that's produced is carbon dioxide. Okay, the B part. Sulfur reacts with oxygen to produce sulfur dioxide gas. Write a chemical equation for this reaction. Okay, sulfur reacts with O2 molecule, oxygen molecule, and it produces sulfur dioxide. And next question, state an environmental problem caused when sulfur dioxide gas dissolves in water in the atmosphere. When the sulfur dioxide reacts with water, it produces sulfuric acid, which formula is H2SO4, and it causes acidic rain or acid rain. Okay, the second question, the diagram shows the electronic configuration of an atom of an element. Okay, complete the table by giving the missing information about this atom. Name of the part of this atom labeled Z. Z is nucleus, contains nucleus, and it locates in the center of the atom. Next question, number of protons in this atom. Okay, we know that number of protons is equal to number of electrons in atom. That's why we should count the number of electrons to finding the number of protons. 1 2 3 4 5 6 7 8 9 10 11 12 protons. Okay, number of the group that contains this element. We know that we can easily know the number of the group of the element using the outermost shell electrons. There have two outermost shell electrons, means that it is group 2 element. Okay, number of the period that contains this element. To finding the number of period, we should count the number of shells, and there are 3 shells. It means that it's located in third period and second group 2. Okay, the next question, the charge of the ion formed from this atom. We know that group 2 elements are metals, and they will make a positive ions, and if this atom can give 2 outermost shell electrons to another element, and it means that it can produce positive 2 charge or positive 2 charge. And next question. This element has three isotopes. The table shows the mass number and the percentage abundance of each isotope in an element, in a sample of this element. Okay. Calculate the relative atomic mass of this element. Give your answer to one decimal place. Okay. And we can easily calculate it from it. 24 mass number multiplied by 79.2% plus 25 mass number multiplied by 10 plus 26 mass number multiplied by 10.8%, and we should divide into percent, into 100, and if we divide it 100 we can easily know the relative atomic mass. Okay, and the answer is 24.316. And they have written that we should give the answer in this one decimal place, and if you convert 24.316 into one decimal place, it will be 24.3. Okay, the next one. Diagram shows the two samples of iron, A and B. Sample B is coated with a thin layer of zinc. Name the process used to coat iron with zinc. It's called galvanizing. Coating the metal or other elements with more reactive metals called galvanizing. And the B part, the two samples of iron are left outside for several weeks. A burnt solid containing hydrated iron 3 oxide forms on a sample A. Give the common name for the brown solid. We know that we call it rust. Give the names of two substances that react with the iron to form the brown solid: water and oxygen. Or you can write air, because air also contains oxygen. Okay, iron can be formed by reacting aluminium powder with iron 3 oxide. The diagram shows how this reaction can be demonstrated. Okay, when the magnesium fuse is lit, a very exothermic reaction occurs. State the meaning of the exothermic. Exothermic means a reaction which gives out energy. Okay, the next one. The question for the reaction between aluminium and iron 3 oxide is 2 aluminium atoms plus iron 3 oxide, and the products are 2 iron atoms plus aluminium 3 oxide. Okay, explain what this reaction shows about the relative reactivities of aluminium and iron. From this reaction we can easily know that aluminium is more reactive than iron, because aluminium displaces iron, means it takes electrons from it gives, and iron gains electrons. The next one. Explain why the reaction between aluminium and iron 3 oxide is a redox reaction. Because aluminium is oxidized and iron oxide is reduced, and aluminium gains oxygen while iron oxide or iron loses oxygen. Okay, the next question, the fourth question. This question is about ionic compounds. The table shows the formula of some positive and negative ions, and the formula of compounds contains these ions. Okay, complete the table by giving the three missing formula. Okay, if sulfur reacts with ammonium, it will produce ammonium 2 sulfate. And if magnesium reacts with nitrate ion, it will produce magnesium nitrate. And if aluminium reacts with carbonate ion, it will produce aluminium carbonate, Al2 CO3 3. Okay, give the name of the compound with the formula NH4NO3, and we can call this ammonium nitrate. Okay, sodium oxide is an ionic compound. The sodium and oxide ions are held together by ionic bonds. State the meaning of term ionic bonds. The ionic bond means it made a bond using electrostatic force of attraction between oppositely charged ions. Okay, the next one. The diagram shows the arrangement of the electrons in a sodium atom and in an oxygen atom. Draw diagrams in the boxes to show the arrangement of the electrons in the ions of sodium oxide, including the charge on the ions. Okay. Nucleus of sodium atom, sodium ion, and first electronic shell, 2 inner electrons, and if it gives 1 electron to oxygen atom, there will be no left electron in outermost shell. That's why there will be 8 electrons. It loses 1 shell. Okay, and it is positive ion because it loses 1 electron, positive 1. And oxide ion, it takes 2 electrons to its own outermost shell. Minus 2 charge because it takes 2 electrons, it gains electrons. And again, sodium ion, it should be the same as the first one. and positive 1. Okay, the next one. The boxes show the displayed formula of 6 organic compounds. Okay, P, Q, R, S, T, and U. Use the letters P, Q, R, S, T, and U to answer these questions. Each letter may be used once, more than once, or not at all. Give the letter of compound that is not a hydrocarbon. We know that hydrocarbons should only contains carbon and hydrogen atoms, and in S1 it contains bromine too. That's why the S1 is not hydrocarbon. And next one, give the letters. It means it should be more. The answer that we give should be more than one letter. Give the letters of the 2 compounds that have the same empirical formula. Okay, the T and U, they are both alkenes and they have the same empirical formula, which is CH2. Give the letter of the compound that is used to manufacture polypropene. And propene, it is U, and the answer should be U. Always the companies use alkenes to make polymers. That's why they should also do cracking. By cracking also they will produce alkane and alkene that's produced by cracking is usually used for polymerization. And B1, describe a test that can be used to distinguish between compounds Q and T. Okay, the test is bromine water for knowing alkanes and alkenes. Result is compound Q. Compound Q doesn't contain any double bonds. It means that it don't react, and the no color change, or the color stays the same. And compound T contains a double bond and it's alkene, means that it changes its color from orange to the colorless. Okay, the C1. Compounds P, Q, and R are members of the same homogeneous series. Give the characteristics of a homogeneous series. Okay, they have same functional group, and they have similar chemical properties. But there is more than 2 characteristics of homogeneous series. For example, the general formula, and each member differs from the next by a CH2, or maybe trend in physical properties between successive members. This is displayed formula of an alkene V. Give the name of an alkene V. Okay, it have 4 carbon atoms, means it is butene. Okay, the displayed formula of another alkene that is isomer of alkene V. Okay. You know that displayed formula is the structure of the organic compound, and isomer is if there is any question about the isomer, isomers are the organic compounds that have same molecular formula but have different displayed formula. Next one. An organic compound has a percentage composition by mass. Show the empirical formula of the compound is CH2F. The empirical formula represents simplest whole number ratio of elements in a chemical compound, and we will calculate it by 12 the molar mass, and it is equals to 3.03. And the next one, hydrogen, 6.06 divided by 1, and it's equals to 6.06. and fluorine 58.58 divided by the molar mass 19, is equals to 3.03. and for ratio of carbon, hydrogen, and fluorine is 1 to 1, and it means CH2F. And that's all. Next one, the sixth question. A student used this method to investigate the reaction of the dilute hydrochloric acid with zinc. Pour some dilute hydrochloric acid into a glass beaker. Record the initial temperature of the acid. Add a piece of the zinc and stir the mixture. Record the temperature of the mixture after 1 minute. Okay. Write a word equation for the reaction of dilute hydrochloric acid with zinc. Okay. Zinc plus hydrochloric acid produce zinc chloride plus hydrogen gas. Okay, next one. The diagram shows the thermometer readings for this reaction. Complete the table giving all values to the nearest 0.1 degrees Celsius. Temperature in degrees Celsius after adding zinc, temperature in Celsius before adding zinc, temperature change in Celsius. Okay. Temperature in Celsius after adding zinc equals to 22.4, as we see, and temperature before adding zinc is 17.7, and temperature change is equals to 4.77, which is equals to subtraction of 2024 by 17.7 by 22.4. And the C1. Another student repeats the method using 5 different metals to compare their reactivity. These students use a polystyrene cup instead of a glass beaker. Explain why a polystyrene cup is better than a glass beaker in this investigation. The reason is polystyrene is insulator, so it reduces heat loss. And also temperature rise or change will be closer to the true value, means the reaction will be more fair. Okay, give 3 factors that the student should keep constant in his investigation. The first one is amount of metal, and the second one is concentration of an acid, and the third one is volume of acid. There is more than 3, and I can tell to you, and there are also speed of stirring or room temperature. Okay, the table shows some of the students' results. Okay, we can see the table. State why there is no temperature change of copper. The reason is copper is unreactive, or it do not react with hydrochloric acid. Okay, the next one. Predict this temperature change for iron. Okay, then for iron, it should be between 1.4 and 5.1. That's why we can put it 3. Deduce the order of the reactivity of 5 metals. Okay, the most reactive produce most bubbles, and it is magnesium. Okay, the next one is moderate bubbling zinc, and the next one is slow bubbling iron. The next one, very slow bubbling tin. And the last one is we have copper that didn't produce any bubble. Okay, this question is about some of the halogens and their compounds. Which element is a liquid at room temperature? Okay, we know that the bromine is liquid in room temperature. Which element has the palest color? And the chlorine have the palest color, and the color of chlorine is pale green. The next one, which is the less reactive? And acetine, because it's located the lowest part of the group 7. The next question. A teacher used displacement reactions to demonstrate the reactivities of some halogens. She adds solutions of fluorine, bromine, and iodine separately to the 3 different sodium halide solutions. The table shows some of the teacher results. We can see the table. A change in color of the solution indicates that the reaction has occurred. Complete the table by predicting the missing results. Okay. Sodium iodide with chlorine solution. Chlorine solution with sodium iodide. Okay, and the solution turns into brown because chlorine reacts with sodium, and iodine element will produce, and the color of the iodine is brown. And next one, sodium chloride with iodine solution. The no reaction occurs because chlorine is more reactive, much more reactive than iodine. Okay, state why the teacher does not add bromine solution to sodium bromide solution, because bromine wouldn't react with bromide, or bromine cannot displace itself. Okay, the word equation for the reaction of bromine with sodium iodide is bromine plus sodium iodide, iodine plus sodium bromide. Write a chemical equation for this. Okay, bromine molecule plus sodium iodide and produce iodide plus sodium bromide plus iodide. And the next one. A technician sees an unlabeled bottle containing a liquid. He knows that the liquid is a solution of one of these compounds: copper chloride, copper bromide, iron chloride, iron bromide. Describe chemical tests that the technician could use to identify a compound in the solution. Okay. First, we should test for cation. For testing it, the teacher should add sodium hydroxide solution. If blue precipitate forms in the solution, it means it contains copper ions. If green precipitate forms, it means it contains iron 2 ions. Okay, and for knowing it have chlorine or bromine, and we should add silver nitrate. If the solution if white precipitate forms in solution, produces in solution, solution contains chlorine ions. If cream precipitate forms, solution contains bromine ions. Okay. Eighth question. Carbon dioxide changes directly from a solid to a gas without becoming a liquid. Give the name of the change of a state from solid to gas. We call it sublimation. And next one. Describe the test for carbon dioxide gas. Okay. We add lime water, and it should turn into cloudy. Lime water is calcium carbonate solution. And next one. Carbon dioxide is a simple molecular covalent substance. Explain why carbon dioxide turns from a solid to a gas at a very low temperature. Because it have very weak forces of attraction between molecules. And the next reason is little amount of energy required to overcome intermolecular forces. And next one, the 6-mark question. Oh my god. How diamond and graphite are both giant covalent substances made up of carbon atoms. Diamonds are used in cutting tools. Graphite is used in pencils to make marks on paper. Explain with reference to structure and bonding why each substance is suitable for its particular use. Okay. In diamond, one carbon atoms made a bond with 4 carbon atoms in a tetrahedral lattice, and the covalent bond between the covalent bonds between carbon atoms are very strong, and therefore the diamond is very hard, and people can easily use it for cutting. And for graphite, In graphite, each carbon atom made a bond with other three carbon atoms, and the structure made by layers and weak forces between layers, and layers can be slide over each other and it makes graphite soft, so it can make marks on paper. Okay, the next one. A student used this apparatus to investigate the heat energy released when a liquid fuel is burned. This is student's method. Measure the mass of the spirit burner and fuel, add 100 cm³ of water to the copper can, record the temperature of the water, use a spirit burner to heat the water until the temperature rises up 30 degrees Celsius. Immediately measure the new mass of the spirit burner and fuel. Suggest why student measures of mass of the spirit burner and fuel immediately after heating the water. The reason is to minimize the evaporation of fuel, to prevent mass loss of the fuel. And when the fuel is burned, the student notices that a black solid forms on the bottom of the copper can. Identify the black solid. By incomplete combustion, there will be carbon. They're made carbon. Explain why the black solid forms. As I said, incomplete combustion because of the oxygen supply may be limited. The next one. C1. Show the heat energy change Q to raise the temperature of 100 cm³ of water by 30 degrees is approximately 13 kilojoules. Okay. The formula is Q equals to mc delta T. Okay. 100 multiplied by, and we know m is mass. Mass is 100 cm³, and here have written that mass of 1 cm³ of water is equals to 1 gram. It means that we can write 100 to the mass, and C is specific heat capacity. Specific heat capacity for water is equal to 4.2 joule per gram per degree Celsius, and we multiply it the temperature change. And I have written that the temperature change is equals to 30, and when we calculate it, it will equal to 12,600, and it's approximately equals to 19 joules, which equals to 13 kilojoules. Okay, the student burns 0.96 gram of methanol, and the which formula is CH3OH. Calculate the molar enthalpy change delta H in kilojoule per mole for the combustion of methanol. Include a sign in your answer. Okay. For finding this, we should firstly find the mole of the methanol. For this, we should divide the mass of methanol that's used and divide it to the 13 32, which is molar mass of the methanol, and it will be 0.03 moles. And for finding delta H, we should divide it. We should divide 12.6 into 0.03, and which answer is 420. And it is exothermic reaction, that's why we should put minus in front of the result, and it will be minus 412. 420. Okay, the table shows the data book values for the molar enthalpy change for the combustion of some alcohols with different numbers of carbon atoms per molecule. Okay, we can see the table. Plot the data values from the table on the grid. Draw a straight line of the best fit. Okay, 1 minus 730 around here. The next one, 2 minus 1370 approximately here, and the third one minus 2020. The next one is minus 2680. The next one is minus 3320. Okay. Okay, the best fit line. Okay, deduce the value of delta H for an alcohol with 6 carbon atoms per molecule. Show on the graph how you obtained your answer. Here and then here, and it's approximately 3900. Next one, minus 3900. Set the relationship between the delta H and the number of carbon atoms per molecule. From the result, we can easily know that the greater number of carbon atoms, the greater value of delta H. Okay, the nitric acid HNO3 is used in the production of fertilizers. Nitric acid is manufactured in stages. There have 3 stages. Okay, complete the chemical equation for the reaction in stage 1. In stage 1, ammonia reacts with oxygen in the presence of platinum catalyst to produce nitrogen monoxide gas and water, and the reaction is will be like this. Okay, give the meaning of this symbol. It means that the reaction is reversible, and state the purpose of the platinum catalyst. The purpose is to increase the rate of reaction. Give a chemical equation for the reaction of nitrogen monoxide and oxygen in stage 2. Okay, 2NO plus O2 oxygen molecule equals to 2NO2. Okay, the next one. The equation for the reaction in stage 3 is 3 nitrogen oxide molecule plus hydrogen plus water equals to 2 nitric acid molecule plus compound plus nitrogen oxide. And calculate the maximum mass in tons of nitric acid that could be produced in the reaction from 11.5 tons of nitrogen dioxide. Okay. Firstly, we should we should calculate the molar masses of nitrogen dioxide and nitric acid. The molar mass of nitrogen dioxide equals to 46, while the molar mass of nitric acid equals to 63. Then we will multiply the tons, we'll convert it into grams and divide it 46, which is the molar mass of the nitrogen dioxide, and there have 250,000 moles. And for finding the mass of the nitric acid, we should divide the mole of the nitrogen dioxide into 3 and multiply it the mole of the nitric acid, which is equals to 2, and the answer is 167,000 moles. And we should multiply the moles of nitric acid into the molar mass of the nitric acid, which is equals to 63, and the answer will be 10 this much grams, which is equals to 10.5 tons. And I think the next question is, suggest what use can be made of the nitrogen monoxide gas formed in stage 3, and the answer is it can be reduced in stage 2 to take more nitrogen dioxide. The next question: when copper to oxide reacts with dilute nitric acid, copper to nitrate is produced. The equation for the reaction is here, we can see it. 0.2 mole of nitric acid reacts with excess copper to oxide. A mass of 15.3 of copper to nitrate is produced. Calculate the percentage yield of the copper nitrate. Okay, first of all, we should find the copper nitrate moles which is used, divided by 175.5, which is equals to 0.0816. And then the next one, theoretically the moles of carbon and copper nitrate, we should divide 0.2 into 2, and which is equals to 0.1. For finding the yield, we should divide 0.0816 into 0.1 and multiply it 100 to convert it into percentage, and it will be 81.6%. I think it's over. Thank you for your attention, guys. Please subscribe to my YouTube channel. It's free and it take less time. Like and comment in the comment part. Thank you. Bye.